the Teams. All right, so good morning. Two of you in Seneca, and there are 4 of you in online, a total of 6 people. So we talked about, in the other class, we talked about, they asked questions about the quiz this week and the midterm next week, and how it's going to be, and so on and so forth. We were going through it. So I am an extremely slow marker. I'm not one of those people who can just mark quickly. Every thing that I mark takes around 20 minutes to mark. So do the math, multiply it by 100 students, see how long it takes for me to mark this stuff. So I told them I can give you the hints for the quiz and test earlier, midterm test earlier, and give you the marks later, which means your marks going to be up during the study break and after study break. Or I can mark you earlier, but I have to then give you the tests a night before. So, and all the other classes said that, please give us the test earlier. And so just to give you a kind of an idea of what the hints for the midterm, because this is in everybody's mind. You know how the quiz is. You've done it already, but midterm is something like this. So I'll bring up essentially what we had last semester, not like 2 semesters ago. So I'll show you that one, so you'll see what to expect, and then we're going to take it from there. So let me just get into this. Log in. So what you're going to see is going to be, sorry, it keeps logging me in over and over. Again, yes. Okay, so yeah, so what you're going to see will be something like this. I'm going to go a couple of semesters back, say bring OOP345, that's that. Then go to midterm test. So what you're going to see in your midterm thingy will be something like this. You see that? Midterm programming details, policy and integrity agreement. And you're gonna, again, like the one that you have done for quizzes, you have to do that to be able to do the midterm. That's number 1. You're gonna have 2. One is the concept and walkthrough, and the other one is the programming. You start the walkthrough. You can choose which one. Actually, no, you start the walkthrough because you're allowed to have a paper, a blank paper with you for your walkthrough. So you start doing the walkthrough with the paper, so you can do the walkthroughs and concepts and stuff. After you're done with that, you close that, you start your midterm programming test. As you see over here, midterm is like 100 minutes for that, 50 minutes for the other one. The reason was that I asked the students, would you like to have longer time for your programming and do the concept and walkthrough, say, after the study break, or the other way? So which means it's going to be, actually it's better to have this one because this one is easy to mark. So I can do the programming test before the break. So you have 100 minutes, an hour and a half to go through it. I do the concept after the break, and you're going to have 50 minutes to do that. Therefore, you have more time to do your test. For this, we have a total of 6 people right now in class. Let me see how many people we have in here. Oh, we have more. Oh, no, we have 6 people over here too. So in your chat, you got to reply to me because I just want to take a vote in all classes and see if everybody's okay with it, and we're going to do it that way. So you guys, to the two guys in here, are you okay to do it that way? To do the concept after midterm and programming before midterm? Questions are going to be the same. You're just going to have more time.
More time, okay.
I'm not going to make the test more complicated because I have more time. The test is the same, but the test is the same, so the same concept, number of questions and delay, but you can have more time to do it.
Okay, and then you have the study break
to do the concept and walkthrough.
Okay.
Is that two people over here? So two people over here say yes. Now, people at home, please answer in the chat, yes or no. Now, don't give me thumb up right over there. I need to see how many people are actually saying yes.
The chat is unavailable, but yes.
Yeah, but just write it down. I need to see. Abhishek keeps telling you. So, that's the thing. You can't, because I'm an extremely slow marker. If I make the programming after the thing, then you're not going to be able to get the answers before the drop date. So I have to have that one before the break. I have no choice with that. Or I can have them all in one day. It doesn't make any difference. So, so three people saying yes. Neil is kind of saying, okay. All right, Neil is okay too. I prefer to finish at the same day. So, okay. So Lily says the same day for everything. Okay. So far. Okay, so we'll find out what we can do. Thank you. Okay, so that's that. And how the midterm programming detail, like when you look at the detail, this is what it's going to look like. It's going to say final. This is final assessment. Why did I say final? It's a typo. Anyway, so midterm functions. These are not your questions, by the way, but it's going to be similar to this. So you'll be given the code from function. You do this, templates, you do that, crash it. So I tell you exactly what the questions are going to look like. And then you're going to see the coding style and requirements, and same thing, and integrity agreement. And that's it. And then you go through that, and we'll see what happens. So that's that. Any questions before can we do programming? No, yeah. No, I already answered that question. All right. Okay, so that's that. I'll tell you what we're going to do later when I talk to all three subjects. You have your quiz this week anyway, so be aware of that, and I will give you the marks, give you the description of the quiz by end of today, hopefully. So let's go back to our current semester. Make sure I'm not making a boo-boo. All right. Okay, so we are going to talk about the standard library today. We're gonna see what the categories give you an introduction of the standard library, and then talk about the categories of the standard library. Go through string library a little, then have an overview of the standard template library to see what it is. Containers, iterators, and algorithms. No detail about it yet. And then for the first half of the lecture, then we're going to talk about type-safe unions. Then after that, we're going to move to the standard template library, which is essentially, let me just bring it up. Just going to bring my reference sheets up. All right. So standard template library. And that's that. And after we talk about the standard library and all the good stuff that I just mentioned, we are going to talk about containers and iterators. And that's that. So one more time. Sorry about that. I thought I had everything ready, but I do not. I'm going to bring this up, and then we'll start. Okay. Yeah, so after that, we're going to talk about we're going to go through the overview of sequential containers. We talk about arrays, vectors, DQ, list, forward list, stack, and iterators, and see exactly how they work. Okay, so C++ is essentially a framework of reusable tools that we have to make our life easier, to be able to do things that in C we had to jump through hoops and create our own libraries to be able to make things happen. In C++, and these fall into these categories. So the categories that we have the, let me just bring these over here. So we have the language support, that the standard library that comes from C, and we have new that is for memory management like SysD and badalloc and things like that. We have diagnostics that are exceptions and the standard exceptions that are for exception handling. We have the general utilities, which are utility, optional, and variant. That handle the move semantics and optional values that we'll talk about later. We have strings, which are essentially string and string view that deal with text management and in an owning way with string, which means it owns its text, and string view that it doesn't own its text and make it much lighter. We have different types of containers, vectors, lists, maps, and so on and so forth, many of them. These are the standard template library data structures. We have iterators, which are essentially like smart pointers that point to the element of these containers. So essentially, when you create a vector of employees, you can create an iterator to an employee vector. Therefore, that pointer points to each element, and it's overloaded with all the things that a pointer can do, which essentially means if you add one to the iterator, it goes to the next element. You can literally point to each element of the containers. We have numerics with math and numeric, because it does all math operations. IO stream, you've worked with it, you know what it is. And multi-threading that sets in thread and future, and also, yeah, we'll get to it. So multi-threading essentially wraps itself around containers and algorithms, so essentially does whatever the algorithms are supposed to do and make them work in a concurrency way, so they're going to be faster to work with. The C string library, it's provides three major ways to handle the text. It does works with C-style strings, which is null-terminated character pointers. You can handle it. Or C++ strings, that is the string object, one object, or a string view that actually works with another string just to be able to access it and work with it. So let's call this one. So string has a one argument constructor, the most common one that you can use. We'll go through the details. So you can use the string exactly like regular variables. It has different operators overloaded for it, that you can use it exactly as you're using a variable. So I have a string, I'll do a plus equal to a C string. It appends a string, and I can do a plus equal with another string, so it appends the two together. You can find out what the size is. The index operator is overloaded at line 15, as you see, so you can see and manipulate each level. You can find out, so the substring of a string from index up to certain length, so you can see exactly, you can go through the substring to go through a string and break it into pieces like that. You can find specific thing inside the string that gives you the position for it, so you can essentially find out where it is. The NPOS, NPOS, it's essentially null position. If anything that's returning a size t is equal to a string NPOS, it means the function that is returning that position didn't find a match. And you have replace, that you can replace a piece of code from a position up to certain characters with another string, so replace it. So it is very efficient. It works with all the good stuff that you, it works with all the memory management and efficiency and all the good things that you need to implement to make your code safe, so you don't leak any memory. But string by itself is a container too, which means exactly like you have learned about range-based loop and things like that, you can actually go through characters of a string exactly as how you did with the other one. So you can actually say with the array that we explained. So you can literally go for CH in message, then uppercase every single thing that you have in there. So as you see it, it's going to uppercase the string. So the range-based loops and everything that you work with the container works with this one too. I've already compiled these things and they work, so I'm not running it. But this is just, for example, to show you. It makes your life much easier when you're actually dealing with. There we go. So makes working with strings much safer. You don't have to worry about dynamic memory allocation, all the good stuff, and it has all the things that you need to do to to apply the rule of 5 to it. So you don't need to worry about it. If you make a string a property of anything, it takes care of itself when the copying and everything is happening. String. Okay. String view. So when you do not need to modify your string and you need to access the information inside, string view is your friend. Why? Because it literally it doesn't own its own data. A string view essentially points to the data of a string and does everything you want to do with it much quicker and faster. So essentially, when you create a string view, I'll call it over here part, and it parts to the C string of full plus 6 and 4, so essentially picks from out of it, and you can literally look at that part of the string using the string view. And string view, remember, it doesn't own the data, which means you cannot modify things where it's just read only. So it doesn't allocate or copy, it's just refer to existing characters. And it's safe as long as the original string remains alive. So if you create a string view to a string and then change the contents of that string, your string views are all screwed up. It's exactly like a pointer. You got to be careful about that. Okay? And it's great for performance with passing substrings to functions, and it shares the exact same interface with string, like substring, find, size, not replace, because replace modifies, but all the queries that you have in the string. So comparing the string and a string view, string owns memory, string view does not. You can modify a string, string view cannot. It is cheap to copy, not for string. String is not cheap to copy, but string view is. It does not have lifetime safety. String view can, if the string is gone, it's gonna lose its data, unmodified behavior. And the string is to build and manipulate text. But with string view, you pass a string around for viewing and searching and things like that, but you don't do modifications with it. Getting into standard template library to see what they are, I'm going to just give you an example, very small little example, to show you what is all about containers, iterators, algorithms, and function objects and things like that. So I'll talk about it, and you'll see exactly what it is. So this is a very simple, it's kind of a look to the future to see how we're going to actually use all these things. So take a look at this. A very simple code written. I am using an IO stream, I'm using a vector, and I'm using algorithms in here. And look at the amount of work that I'm doing. I'm creating a vector of numbers. That's containers. And then I am sorting the vector, and the sort algorithm does it perfectly. Then I'll go through every single one on display. Then I'll do a binary search in the vector from the beginning to the end to find if there is a 3 in it. And if that thing returns true. So that binary search is extremely fast. And all the things that you see over here are built in the standard template library. So if I wanted to do this, say for series of students, all I needed to do over here is to have a vector of students over here. For sort, I could actually provide a lambda expression to sort the student based on whatever I want. I could overload the equality operator, the to assignment operator, to check a student with a student number. Doing so, I could search binary search, and instead of free, I put over here just the student number because it checks for equality and less than and greater than that you do, so you could search for binary. So these things are the amazing things that you can do with the standard template library. Now, we talked about unions, and when we said when we create unions, unions are essentially like structures, but everything overlaps in it, which means when I created a union, I created a union of integer and a long and a constant character pointer. It literally puts everything at the same place in memory. Doing so, I can use the same piece of memory for different things when I don't want to use them at the same time. This is to save memory. When you're working on small devices, these days, things are going so bananas that you don't have any small device anymore. So when I say small device, what I mean is the microphone that I'm actually wearing now, or the mouse that you have. Not your cell phone. Your cell phone is stronger than any supercomputer we had 20 years ago. So that's not that's not what is this for. So something that has 2K of RAM. Okay? When I say 2K, I mean 2K, 2000. Okay? 2K. All right? So instead of union, because union is extremely low level, you can use what we call a variant. Again, you're not going to have a use case for this probably in this semester, maybe if we instruct you how to do it. But when you create a variant, that's again a template library, as you say, you can create a variant with different types, int, double, and string, and you see, it's going to put all the three together. So when I say, and then when I say v is equal to 3.14, it will know which one to set it for, because it knows it's a double over there, therefore it sets the double one, and you can do a get double, and that'll work that way. And then I can set the variant to the string. No, it knows it's supposed to be the string, and the string is going to be shown to. And the index that it actually shows, it tells you which one it is. So the index is 2 over here, and it shows that one. So variants are essentially overlapping all these objects together and saving memory. But if you put something in a double, the string is screwed up. If you put something like, so when we actually set the V to OOP345, the double is gone. If you use the get for double when you have a string in it, it's going to throw an exception. Okay, and that, like that, you can actually know what's going on. So, and the exception that it's going to throw, it's going to be the bad variant access. So essentially, in here, if I do something like this, try, and now in here I have to have exceptions. Okay, so if I say over here, cout get int, v, it's gonna be catching bad access. So I'm gonna say this will be thrown. because there is no integer in there. You okay? So it's much more easy to handle than a union, because like that you have to actually keep track of everything and make sure you set the things and cast it properly. So that these are variants. And again, a cautionary code to write is this. So if I say over here string text OOP345 rocks, and I set that one to text, and then I show you the before and I set that to updated, if I print the after over there, the outcome is going to be you don't know. Okay? We are lucky right now, so it's unpredictable what the before and after is going to be. So string view is supposed to give you updated, but it's not giving you updated. It gives you updated and some other stuff. So it is unpredictable. You cannot use string view, because when string view was set to text, it knew that the size was such. Now if this updated gets bigger and string has to reallocate to some other memory, it's possible that you're gonna just even crash it. So I don't know, again, as it says, it's unmodified. I do not know. But when I'm gonna just run it and see. There you go. You see that? So it's completely unpredictable. Now, because when the size is smaller, string is smart enough not to reallocate memory. It uses that one. But when you make it bigger, now it has to resize. Therefore, be aware of it. Extremely important to know.
And why does that happen?
Pardon?
Because why does that happen? Because we're using string view?
Yeah, because string view is to view a string.
Mm-hmm.
If you change the string, because the data string view was pointing to the previous version of the string, it gets away. You have to make sure if you are passing a string as a string view to just view what it has, you have to make sure you don't modify it. If you modify it, you have to reset it.
Reset, okay.
So
reassign it?
yeah, so if essentially, again, if I set the view to text again over here, then it will be fine.
Okay. But otherwise, this is unpredictable?
Yes, it's completely unpredictable. Yes.
When you reassign the text, doesn't it add a null pointer after the reassigned text?
When I assign what?
When you reassign the text to updated, doesn't it put a null terminator after the exclamation mark? So the view, why does the view still print the CKS?
We call it unpredictable for a reason. Because you don't know how string is implemented.
Is it not like just PowerPoint?
I have no, we don't know. They are making it, we don't know how string is implemented, okay? You can actually go hack it and look at the source code of the library and see how string is implemented, but good luck with that, okay? So that's why we call it unpredictable. All we say, if you are using a string view to access the data of a string faster, you have to make sure you don't change the data. If you change the data, you have to set the string view again so it actually gets access to the new data.
Sorry, why do we use string view? It's faster, you said?
Oh yeah.
Yeah.
Let's say you want to show the content of a screen and you want to pass it to an object, to a constant object thingy.
Mm-hmm.
So if you pass as constant string, then it's gonna create a new string copying everything.
Okay.
But when you pass a string view, it doesn't copy. It's essentially a pointer.
Yeah, and it just
That points-
shows them.
It shows, it searches, it does all the queries it can do to a string, but no modification.
Okay, And no allocation for.
No, yeah, no allocation, nothing. You're literally the size of one pointer.
Okay.
So it's very, very efficient.
Nice.
Now, we're going to have an overview of containers and see what they are. So, containers are essentially templates that hold collection of objects. That's what it is. Now, that collection, how it is, it all depends on the data structure that it's using. We have sequential containers that are essentially holding things back to back. These are arrays, vectors, DQs, lists, forward lists, and things like that. You have container adapters. When we say an adapter, it means the object that you're creating is a standard data structure. But what it is essentially, it's a wrap around an already existing container, just to make that container act like a specific thing, like stack. Like a stack is a first in, first out thing. So a stack, whatever you put in a stack, the last one that you put in is the first one that it only has a push and pop, and that's it, nothing else. It's essentially wrapped around probably a vector, but just make sure that you only use what you're supposed to use for a vector. And then we have associative containers that we're going to cover it later, set and map and stuff like that, okay? So, array. Now, an array is fixed size. It cannot grow or shrink. It's stored in the stack. When I say stack, I don't mean the data structure stack. Memory, stack and heap, it's stored in the stack, okay? And it is fast, but it has size. You can find its size. You can find what is in front. You can find what is in back. You can do fill and you can do at. So you can do these stuff with an array, but it's literally a wraparound regular arrays that we had in C language. So you create an array of 5 integers over there and you set it to something. As you see, you can see what is the size. You can see what is at the front or the back. You can go through it with ranges book. You can modify elements. It's literally an array, a wraparound, a regular array. Just going to run it, make sure it works. These I didn't test. Yes, there you go. Okay, so that's that.
Heap was dynamic memory is the stack.
No, dynamic memory is heap.
Heap.
Heap is where all the executables in your computer, the place that all the executables in your computer share. And they compete for it, asking the operating system. So essentially, operating system is the tenant. It rents you what pieces of memory it has. And you do that using new. That's essentially it. So that's heap. When you create an array, your executable grows. Because it's essentially in the executable.
Yeah.
But when you create the next ones, it doesn't grow. We'll go through it. Okay, so now this one is an array. STL array. So now we have a dynamic array. Now, a dynamic array, we call it a vector. So essentially, vector is contiguous storage. It is it's like a dynamic array with kind of a booster, okay? It is very fast. It can resize itself as you push back or you insert values in it. The key methods that you use its size, you see what is the capacity of it, you see if it's empty or not, front and back, and you can clear the values out. It's best for fast lookups and append operations. Okay, fast lookup and append. So essentially they say at any time you want to create an array, you create a vector. Let's put it that way. Whenever you are thinking of an array, you create a vector. It's the most common STL used out there. Okay, let's put it that way. So as you see over here for the vector, I'm creating students, then I'm pushing back Danielle over there, or Daniel, and I'll exactly like with a range-based loop, I show all the students. I can see what is the size. I can insert student. Now, you see over here, students begin. This is actually an iterator. So begin is the iterator pointing to the first element of a container. We're gonna soon show you how to actually keep it somewhere and use it, okay? So now I can say erase begin plus 3. This plus is overloaded with the iterators to say if I do plus, it means go 3 times further. And because all the iterators come from the same abstract base class iterator, what happens is that when you actually create them, the iterator that works for a stack that is contiguous works the exact same way that it works for others that are not. So if you do plus, it actually goes to this. I'll show you. So pop back takes something. So you can, with stack, you can do pop back, pop front, you can do pop you can do push back and push front. So it works in any way you want. Once when I was teaching these things and they are saying why you are teaching all this stuff in OOP345. But you need to know that to be able to use this, okay? To appreciate it when you went through all those dynamic memory allocation stuff, and now, poof, it's doing it for you in a. Anyways.
Does that mean we should use this for our assignments from now on, or is it still?
Always. If you want to use an array, yes, use a vector. Unless we specifically tell you not to use a vector.
Oh, okay.
Yes. So use STL as much as you can. It makes your life easy.
It feels like a cheat.
Hmm?
It feels like a cheat to not have to write.
That's a beautiful term to put it. C++ is a big cheat. The STL is a huge cheat. It gives you everything that you need to build an efficient application and quick. You just need to know it. The problem is that people don't appreciate that they have to first learn the hard way to be able to use it. It's like you first learn how to drive a car, and then you sit in a self-driving car. Now you can supervise it. If it goes bananas, you can hold it. But most of the time, you just sit and let it go.
Yeah.
Okay, it's the same. It's exactly that. So you need, and this is something that we have to put emphasis on. It's extremely important. You told me it's a cheat. I got goosebumps because that was a beautiful thing to mention. I'm going to mention all the other classes too now. Okay, this is true actually, very true. GHI, so STL vector. Hopefully, I'm going to go in more detail. Double-ended queue. DQ.
Sorry, sir. What did we say about containers quickly? Like, containers are. I didn't really.
Array.
Arrays. They're. So they're arrays. Containers.
No, I cannot say. Do you know a little bit of math?
Yeah.
Do you know what a set is in math?
Oh, okay. There, I know.
Okay, collection. A collection is a container is a collection of things.
Okay.
Now,
Like
how
a
do you do your collections?
Mm-hmm.
Like, you lay them back to back on a table, or you just drop them on a table like a mishmash and you pick what you want, or you put small chunks of pieces around your table. It's still the containers. You have stuff in it. How do you organize stuff? That's different types of containers that you see.
Okay.
So when we say an array, it means they're all straight like that in a stack. When I say vector, it means it's still all back to back, but it's in heap and it's quick for this and that. And I'm going to go for a DQ, so I'll explain exactly now what is this one. So the DQ is essentially fast insertion and removal in both ends. Vector is not as fast as this one. Okay, so whenever you have, you are creating a queue and you want to quickly remove and add to both ends, then DQ is your friend. It's not contiguous in memory, so your DQ may be in 20 different places in memory. It's not in one. That's why sequential accessing it is very, very expensive. Because in a vector, it can calculate what is the address. If you say the 10th one, it's going to pick your 10th one. But if you say 10th one over here, it's as if you have 10 boxes on the table and it has numbers on it and you have to go 1, 2, 3, 4, 5, so that's 10 and pick it up. Okay, so it's not bad. You cannot find the elements using their address. Okay? It is great for, they call it sliding window. Okay, sliding window programming, as if you have a window over something that you want to look at stuff like that. It's not good for random access, but you know what I mean by sliding window. When you scroll up and down, you see the text going up and down.
Oh, yeah.
It's great for that.
It displays what you
It
want.
just displays what you have. It's very difficult to go to the first and the back. It takes time. Okay? It's good for queues and history buffers, for example. Like when you are adding history to your browser, DQ is your friend. Okay? Lists and forward lists. These are literally linked lists. I used to actually come to class and code a stack. Did I give you a code for a stack in this class? I used to come out and actually literally code a stack. Maybe I'll do it today, I don't know. To just tell you how these things are done behind the scene, but because you will do that in your data structures, it's redundant. If I get time, maybe during the lab I'll do it, but we'll see. So, this is what we call a doubly linked. Doubly linked essentially means each knows its previous and next. We have a camera, let's do this. But I don't have a, did I bring my, no we don't. Darn it, okay. I thought I have a marker, but I don't. Sorry, I came directly from hospital and didn't have the stuff in there. So for a doubly linked list, this is how it is done. Take a look. So this is what a doubly linked list is. Actually, it's even better than marker. Nicer and cleaner. The center over here of these are where your data is. Okay? Now, the first one and the first one and last one are pointers. So this is essentially, this is called a node. Okay, this is a structure of type node. The entire thing together, so this is node, and what you have over here is this. This is node, and this is, I'm just going to call it linked list. Linked lists have different types. I'm not going to go into details, but linked list, it has put a few pointers in it. I'm going to just put 3 of them. And I'm going to call this one head, and I'm going to call this one tail, and I'm going to call this one current. So this is head, tail. So head always points to the very first node that you have in a linked list. Tail always points to the very last one in your linked list, okay? Each node knows exactly where the next node is. So this is pointing to this one. This is pointing to this one. And this is pointing to this one. And this one is pointing to null. So we know it's the last one. And I should have made that one, but it's okay. And then this one points to the previous one. This one points to the previous one. This one points to the previous one, and this one points to nowhere, which is the first one. So as you see, this and current is the one remember I told you sliding window? This is another thing that can be used for sliding window. So this points to the current one, the one you're dealing with now. And you can go to next, oh, you hit the wall. You can go back. So you can, with the current one, you can traverse through this thing. But imagine if I told you go to the 50,000th one, you have to go next. It's not somewhere in memory that you can find out. This is a doubly linked list, okay? And that's what you have. Each node knows its previous and next. There is no random access, which means the subscription operator, the index operator is not implemented for this. You cannot use index operator for this because it's extremely expensive. You could, but it's extremely expensive. And it's best for frequent insertions and removals. Why? Because it is done in a way that if you just create a new node, somewhere, it is very cheap. It is very cheap to insert it in the middle. All you need to do, if I want it to be between this and that, all I need to do is to make this guy to point to here, this one to point back to here, one point to here, and I remove the links over here, so I'm not going to have the links, and it literally sits where it's supposed to sit, and everything is done. So obviously these two are going to be gone. These two are going to be removed, okay? And this one is going to point to here. So inserting one node in the middle doesn't cause any shifting anywhere. That's why it's extremely efficient. But it has lots of overhead. So look at it. For each node, for each piece of data, you need to have 2 pointers added to it. Okay? And keep that in mind. If the comparison with size, if you relatively have a big data, then it's good for you. It doesn't make any difference. Like if each piece of data of mine is 2K, then who cares about the 8 bytes? But if you're holding over here single characters, and that sucks because for each single character, you need 16 bytes. 8 bytes for one pointer, 8 bytes for another pointer, it goes banana. So again, it all depends on what you want to do. But if you want to do rapid insertion and removal of a character, then you're going to pay for the memory to gain access. It's always a trade-off. The more efficient with memory it is and quicker with insertion and removal is. So if I want to remove this node now, if I want to remove one to the last node, all I need to do is to update the pointers and delete this one. No shifting is required. Everything's going to work perfect.
But the linked list is bad at iterating through.
Yes, it's awful. Awful for that. Awful. We'll go through it soon. So that's that. So this is a doubly linked list. And again, as you see, I have numbers like this. And now I'm introducing an iterator. Look at line 11. I'm saying iterator is numbers begin. So it essentially becomes the iterator that points to the beginning. Now I can say advance the iterator 2 times. So essentially it means go 2 times further. I could do 2 plus plus, it's the same thing. Then I will say insert at the iterator 25. So it literally did what I've done with the white one over here. It inserts it in there. Then I can go through it again. The range base works for it. You can start and go through it one by one. There's no problem with it because it's a list of integers. I can use that, or I could have used an iterator for it. Absolutely no problem either. Then I can do remove and the same, so on and so forth. So everything works exactly as you see.
Dot remove removes the first instance of 25. The line number 19.
Yes.
Oh.
Again, it's done for that purpose.
Okay.
Oh, sorry, list. That's DQ. Oh, I already put the DQ, did I?
Yeah.
I already saved it. So I need to, okay.
This one was list.
Oh, this is list. I talked about DQ and I brought in list. So did I put the DQ in? The DQ code at all?
We did.
We did? Okay, so list, list is essentially is a doubly linked, so it's not a, so it's a list. So list, it's J-STL list. That is a doubly linked list.cpp. Okay.
Sir, so in line number 7.
Sorry. I'll bring it up. Line number 7.
In 7, oh, it was the other one though, in list. Because you actually called list.
Give me a second.
So yeah, in line number 7,
Mm-hmm.
so list keyword, how is that different from declaring like a vector? So in memory, it's organized
Oh
differently.
my God, a vector is sequential. It's an array.
And this list, how is it organized?
I just put it for you.
It was like randomly, right? Like, well, it's pointed to...
Every single thing that you add, I think I have to write the code for you to see, because every single, so 10, 20, 30, 40, it goes like that, all over the place.
So it's random.
Complete, it's essentially each one is a request for a new from the operating system.
Mm.
And they're all in the heap. None of them are in the stack.
Got you. But they're pointed to, so that's how they know.
Yeah, so what you create is this blue one over here.
Okay, that's the keyword.
That's the one. So this object is created for you.
Okay.
So when you create list int numbers, you only have this blue one created for you.
Mm-hmm.
Okay? When you set equal to yada yada, essentially it keeps pushing back to it. One by one, the elements of that array will be pushed back to it.
Mm-hmm.
And then you're going to, okay?
Makes sense.
Okay, so okay. Forward list. He's even worse. Like, a forward list, okay, is a singly linked list, which essentially, I'm not going to draw the whole thing for you, but just for you to know, it is like this. So you have that, and you have a pointer, and you have that, and you have a pointer. Okay, so this is pointing to next one, and there's no going back.
Mm-hmm.
For some reason, the mouse thingy, the way they click, there we go.
But the other one was doubly, right?
The other one was doubly.
Okay.
So this one has something like this. And what you create, I said I'm not going to draw it, but I did it. One is the head, and the other one is the current one you're dealing with, whatever it is. Again, many different implementations. I'm just giving you one example of it. So this is the head. Okay. So why using this instead of doubly? It saves memory. It's one pointer per node, not two. It's singly links. It's traverse forward only. It doesn't go backward. It's best for lightweight streaming style structures. Things that you want to go back to back and I don't want to go back. Stream is what you type and it comes. Like you get the values one by one and you can't go back. That's what it is. Yeah, so you can push front, then I create an iterator to the beginning, then I'm going to say erase after, you do it like that, so it, yeah.
So is this faster access then compared to the...
No,
No.
it's just more memory, less memory.
Less memory, okay. Because then...
And you will see wrappers that I'm going to put around these, you will see later that each one of these come handy for a specific type of data structure.
Okay.
And that I'll show it to you. It's difficult to explain what is a good thing to be used,
Right.
but I can show you some examples.
But these are tools for the right purpose.
Yes, you have to find the right use for it.
Mm-hmm.
For now, we are rookie. We're gonna use vector for everything. You know what I mean? But when the time comes and the speed and like you are building the code for that self-driving car, speed because you're gonna kill someone, you have to make sure it goes as fast as possible. That's when you. Okay. So this is forward list. Oh, I'm keep writing J. J, this is K. K, this is K. K, this is J. 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 K, this is this is L. Forward list. Now, the next ones are container adapters, okay? When I say container adapters, these are not really anything new. They create a class around an already existing container that I showed you, okay? The first one is called a stack. Okay? It only has push and pop. You can push stuff into it and pop. You always have access to the last thing that was added into it. If you didn't have this structure, you couldn't make a function call in any language. This is how the function calls are done. So at any moment when you are calling a function, the address of where the function call is pushed into a stack. And then the program goes to, the CPU goes to the function to run. If in that function you have another function call, exactly where the address of the function call was is pushed to another stack, to the same stack. And then it goes to that function. Every return statement in a function is a pop. It pops the last place it was pushed into, therefore it knows where to go back to. And when the stack is empty, you're in main. So where to use it? This is a forward list that only pushes and pops. You only have access to the last one. So it's not, so it's exact opposite of what I showed you over there. You only have, so with this, can I do undo on this? It's this only. So push, push, push. We call it top. That's it. You only push at the top and pop from the top. You have no access to the end. You can keep popping until you hit the null. That's a stack. And the terminology for a stack is first in, last out. The very first thing that you insert is the last thing that's coming out.
Wait, a stack is first. Oh, yeah, last out.
Stack, first in,
Oh, yeah.
last out. So they're last in, first out. Same thing.
Yeah, I've heard
Last
people
in,
say
first
first in, first out.
No. First in, first out is a different thing.
That's cute.
Yeah, last in, first out. Again, these are adapters. These are wrappers around already existing containers. Then we have queue. A queue is first in, first out. So essentially lineup that you have in Tim Hortons. That's a queue. The first one in the queue will be a, so you push, oh, yeah.
But sir,
Yes.
why did we learn DQ first?
Huh?
Why did we learn double-ended Q first before Q?
Why didn't we?
Why did we? Because it's like, a Q is like the basic one, right? And then double-ended Q is like,
Yeah, it has more than bells and whistles in it.
yeah.
That's why you learned it first. And then this, a wrapper essentially, these adapters, okay, when you read data structures, these are all textbook stuff that you're gonna learn. All textbook, like you start first, they're gonna start about arrays, after arrays, they're gonna talk about stack, and then after stack, they're gonna talk about this. And the code writing for these is very simple, actually. It's very easy, like stack It's just a few lines of code. I can show it to you. It's very simple. Okay? The thing is that those people who actually write the STL libraries, they want to add more capabilities. Then it becomes a little more complicated like that. For those people who want to use already existing containers only with the features of a queue, not to make any boo-boos, do that, okay? So this is first in, first out. This is a queue. And then we have a priority queue. Priority queue always keeps the largest on top. Now, when you say largest, it depends on the definition. Okay? So let's say you are creating a queue for an Alpine, and you say children and seniors first. So when they're added to the queue, you give it higher priority. This is what it's that for. Okay? So whenever you are pushing something into it, always the biggest one. Now, biggest one, again, if you have a class, overload the less than and greater than operator in it, and it will take care of it for you. They all just make sense. Like that, it's all the stuff that you have done with operator overloading and stuff come handy over here. So if you want to use a priority queue and keep everything ordered when you're actually putting something in so that greatest one is always at the top, that's what you do.
And we define what the largest means, right?
Yeah, you have to define what the largest is.
Is there a definition in that one? Or
Definition of what the largest is?
in this one? Or is default just the greatest int in this code?
The greatest. Whatever the greatest you define in your...
Okay.
So you define using the operator, you overload what... Yeah.
Okay.
So you define what greater means in your class, and this is going to use that one to apply whatever is supposed to be applied. So STL, wow, I wrote, what is this? That's Q? What kind of Q is that? I just wrote what I saw what I wrote. So this is essentially priority queue. Priority queue. So why these things are called adapters? Essentially, because a stack is essentially a DQ. It's a wrapper written around DQ that only allows push and pop from the top. A queue is essentially a DQ that only allows you to push back and pop front. So again, stack, you have a DQ that pushes and pop top. So they literally call those functions in it. A queue is a DQ that pushes back and pops front. And priority queue is actually a vector that always makes sure it's sorted when you are actually adding the stuff in it. So what are the iterators? Iterators are essentially like smart pointers that allow you to traverse through a container, okay? So as you see over here, look at the for loop that I have written over there. I'm writing for vector int. So you mentioned, so iterator essentially each container has an iterator class created in it that you have to instantiate out of that one. That's how it understands this iterator to what type of a container. So if I want the vector iterator, you're going to put right vector employee iterator I, which means only vectors to employee that I think he can iterate. Okay?
So it's a class inside a class.
Yes. Okay? So I'll say vector integer iterator it equals nums begin, and I'm going to say while this iterator is not nums end, which means while it's nums end, so when you write a container end, the iterator it returns is one after last.
Okay, the index, not the.
It's not index, it's an iterator.
Okay.
Iterator is essentially a pointer pointing to a specific element. Okay? It's a smart pointer pointing to the beginning of an element, to an element. And there are two standard ones that you can always extract from a container. It's begin and the end. So any container dot begin gives you an iterator that points to the very first element of the container. That container dot end returns the iterator that is one after last, which means if you reach to it, it means you have to be already stopping. That's why we write for vector int iterator it is equal to nums begin, iterator not equal to nums end. It means while it's not end, keep doing whatever, plus plus int or int plus plus. It literally adds, goes to the next one, points to the next one. It doesn't mean plus plus with it's an overloaded thing. Essentially means go to next element. And minus minus goes to the previous one.
So the end doesn't point at the end?
No.
It points at the
One before end. So nums end, if I say it is equal to nums end, I have to do it minus minus to see what is the last one.
Very gotcha.
Okay? And also, the target of operator is overloaded for that iterator. When you do that, that means the actual element.
Okay. Otherwise, without the pointer, what do you get? So you wouldn't get the actual value, you get the index without the pointer?
Without the pointer, you have the iterator object.
Okay.
The asterisk is overloaded. It's not target of as you have for pointers. Remember smart
Okay.
pointer? Okay.
Right. So it's different in this case.
Yeah.
It's
Did we do smart pointers yet or we didn't? No, we haven't done. Okay, shoot. Okay, so that's why you don't know. So the asterisk is actually overloaded for an iterator.
Okay.
It's not really a target of for a pointer.
Okay.
I'm going to implement a smart pointer in class for you so you'll see what it is. A smart pointer is essentially a pointer that you don't have to delete anything for it. It knows when to delete.
Okay.
So all the pointers that you had when you say equals new something and you had to worry about, oh, I have to delete it. Smart pointer, you set it into the new piece of memory. When it's gone, automatically it deletes its content.
Okay.
We'll come to it. That's why they call it smart pointers. But anyways, we'll come to it. I'll explain when the time comes. Element O.
Gotcha.
Piece over here, iterator basic. Now, just to demonstrate inserting and erasing with iterators, now I have a list of nums as you see. Now I'm going to say insert iterator 25 and I say -1 and then it's, see. So now I'm saying it inserts before 30 when I say, so iterator 2 points to the second one. Then I'm going to say insert 25, it's going to be between 20 and 30. Okay, then I'm going to say erase minus ID. It's going to remove the one before the 25 that is added, which is 20. And that's removing and inserting with iterators. Now, when you are dealing with iterators and you create so when I say over here auto IT equals to begin, you can create an iterator that cannot change a list. When you have this list, if I pass this list as a constant to a function, then this iterator is not going to work with it because it is constant. You can add a C to the beginning of begin and end. So auto C it is nums.c begin. This gives you a constant iterator to the beginning. So you cannot change, you cannot erase and stuff with it. You can just read the values with it. So if you're passing something to a constant, yeah, you need to do that. So this, if you need constant iterator, if you need read only iterator, use C begin and C end.
So for example, line 12 wouldn't work with this?
Pardon me?
Line 12 wouldn't work with line 8 then, the erase. We would only be reading.
Yes.
Okay.
Yes. Okay. What I'm going to do, I'm going to give you a series of MD files so you can see. So I created a few things over here. Give me a second. That I want you to go through. Yes, for example, I did not mention these things that I'm going to mention it to you. So I'm going to give you an MD file for strings. So let me just add this over here. Existing item. These are my cheat sheets that I prepare. So we need this. Seriously. And I want you to actually go through this. Okay? So if we open it as MD, it's going to be easier. So it's going to look like something like this. Okay? So it goes through strings and things that you need to know about it. It's little examples: concatenation, accessing and modifying, properties, what are the properties that we have, how to find substrings, so inserting, erasing, replacing, string view. So everything over there, so, and it explains to you exactly what is string good for, string view. Please go through this to see what strings are. It's very important. So that's there for you. Then we have, how much time do we have? It ends at 9:45. Okay, so we talked about we talked about vector, we talked about lists, we talked about DQ. Oh, this is something that we didn't talk about. Set. So, what is set for? It only accepts unique elements. So it ensures no duplicate stuff is happening. Now, how does it find out if it's duplicate? It checks with the equality operator. So again, if you are using it for anything, you know how to implement what is equal, not to insert again. If if two students are checked for equality, it checks their student number. Stuff like that, okay? So you can do like this. When you insert, it inserts everything to the set, and what happens is that it completely ignores the ones that are duplicated. It quietly ignores it, okay? Also, when you are inserting, it doesn't matter where you are inserting, it always will be sorted using less than and greater than thing that you overlook. Yes.
This is a container, sir?
Yes,
Okay.
it's a set. It's literally called set. You see? It says set int numbers. You see that?
Mm-hmm.
Okay. So that's that. It has no random access. You cannot find anything by index, and is much slower than sequential access like vector. But it is very good to keep things insorted, and if you want to actually see if something exists in it, it's extremely fast to find out if you have something in it or not, and extract it, okay? So essentially you can say find 25, and it immediately, in 2 seconds, it tells you if it's there or not. Anyways, so
So then it's not good with memory. Is that the trade-off, the memory?
no, it literally keeps it in a binary tree, but you'll find out in DSA what it is binary. So when you insert it, it automatically insert it at a proper place. That's what a set is. So you use set when you need unique elements and you need automatic sorting. And yes, you can use it for whatever you want. Oh, I should have called it STL set. Okay, dictionaries. When you want to keep pair values, map is your friend. Remember I told you anything you want, you can find it in here? You create a map of a string and an integer. It means it keeps those pairs. So now you can say phone book, and the first one becomes the index, and the second one becomes the value. And it literally searches for you in it. So you can always print phone book Bob, and it finds that number and takes it out for you. It's called a map. Very useful.
Also a container?
They're all. We are
all
teaching.
these-
We are teaching standard template library, and this is a container.
I'm trying to figure out what the differences between adapter, a container adapter, and
I don't know if this is an adapter or not, quite frankly. I don't know if map is an adapter or not. Let me check. That's a good question. Let me check. No, it's an associative container. Yes. So it stores element in the way that it automatically maintains ordering and allows fast lookups. Okay. So it keeps stuff by association. Yeah. Okay. All right. So we were talking about sets, iterators we went through. And about constant iterators, I should mention this. And let me mention these two. So this is this was let me delete this. STL map. So about iterators, there are two more things that I have to mention, and I put it in here, and I forgot to put it, give it to you. You can go, if you don't like to use minus minus, you can use backwards iterator. You can say R begin. You see that? So R begin becomes the last, R end becomes one before the first. And when you do plus plus, it actually you're going backwards in a container. So that's the reverse iterators. And constant one I mentioned to you already, but how to create a constant one other than auto. When you use auto, it's you don't know what the type is, so this is the type. So you see set constant iterator numbers beginning yada yada yada. So either you go, yeah, and it actually creates a constant iterator out of that. Or you can use auto C begin and C end. So vectors, frequent insertions, removals, list, random access, DQ, memory efficiency, set, duplicates, so yes, and map is for key and value storage. Containers fast access, list frequent insertion removals, DQ insert or remove, set are unique, duplicates are avoided, and key value and storage. I want to see if there's anything else over here. How much time do we have? We are done. Yeah. Okay. And many of these things that I mentioned are not in the notes, or they just write a title over there and doesn't say anything over there. These are the things that I find most important. I got a couple of more things over here. Iterator utilities. Remind me to talk about it the next time. Iterator utilities, like you have helper functions written, like for example, distance between two iterators. You can go distance between beginning and end to see what it is. Advanced, you saw it already. Next tells you what is the next. So essentially returns a new iterator, an advanced forward and backward without modifying the original one. Next and previous. You can swap iterators. Back inserter ones. I have to go through this. So I can actually do that when we are going to algorithms. So we can do that too. But anyways, time's up and we need to go. And I'll see you the next time. Okay? Let me just put this thing in. I'm going to look at it. And Lily, Lily, are you there? Is Lily there? Hello?
Did you
No,
find me,
she-
Professor?
You're there?
Yep.
Okay. Later on, if you don't mind, let's have a quick talk. Okay?
Yeah, sure.
Okay. Whenever you have a chance, let's have a quick talk. Now I have to run, but afterwards, let's have a quick talk. Have a good day, and talk to you later.